everyone, and thank you for attending Modular's MineCare Cloud Maintenance Management webinar. We know your time is important, and we thank you for taking the 30 or so minutes to join us. Today's presentation will focus on some of the new features and capabilities of the MineCare Maintenance Management solution. You'll learn how implementing the MineCare solution's advanced analytics and cloud computing capabilities can benefit your mine by identifying problems early to maximize uptime and decrease maintenance costs, effectively managing big data and avoiding information overload by collecting the right data at the right time, streamlining your maintenance practices to improve equipment and labor utilization, promoting a proactive maintenance approach to reduce unscheduled downtime and extend equipment life, and leveraging the Internet of Things, IoT, to connect and monitor your entire fleet from one central location. My name is Alyssa Wedler, and I am the Marketing Communications Specialist at Modular. I'm mostly here to handle the administrative side of today's webinar. This is an interactive webinar, and we encourage you to ask questions. To do so, simply type your question into the chat box window at the bottom left of your screen at any time during the presentation. The presentation will last approximately 20 minutes, and we will allot 5 to 10 minutes for question and answer immediately following the presentation. If, for some reason, we do not get to your question, we will follow up with you via email within approximately 48 hours. This webinar is being recorded, so we will mute everyone's audio except for the presenters. Our presenter today is Simon Van Wiegen, Modular's Product Manager for Maintenance Management Systems. Simon joined Modular in October 2013. He has a bachelor's degree in mechatronics engineering, as well as a bachelor's of computer science degree, both from Deakin University in Australia. He has 9 years of experience in the mining industry, working with Rio Tinto at multiple mining operations before joining Modular. He has held various maintenance roles, including reliability engineer, maintenance engineer, monitoring and control engineer, and asset health specialist. Simon is currently based out of our corporate office in Tucson, Arizona. And with that, I will now hand the presentation over to Simon.
Hello everyone, and thank you for this opportunity today to talk about some of the latest innovations in modular mining systems in the asset health and maintenance management space, where we're really starting to leverage some of the key latest technologies around Internet of Things, cloud computing and analytics, and how we can use that to assist in driving a better approach to maintenance management on the mine. So really in line with Modular's vision, which is to revolutionize the way the mining industry operates in real time, this is really in line with what we're doing with maintenance management, and really looking at how we can use some of the latest technologies to really drive an improvement in the management of operational and maintenance data to improve reliability of the equipment across the mine site. One of the key advantages that the MineCare system provides is that it is really designed to integrate and complement all elements of the maintenance workflow cycle. So from identification of problems on the equipment, we were able to better identify problems as they occur and identify critical items at the right time to provide the effective response process on the mine site. We're also able to provide assistance with the planning and providing the key information necessary to assist planners with what information they need to provide the right resources in response to a particular work item. We can integrate with the scheduling of maintenance activities, where we're able to help optimize the time at which the maintenance takes place and really work towards driving a condition-based approach to maintenance. And following on into the execution of the work, where we're able to deliver the information to the people performing the work to maximize the time on the tools. And this is really about ensuring that maintenance technicians have that key information so they can avoid unnecessary trips and unnecessary stoppages, and ensuring that they have everything they need to perform the work, where troubleshooting and diagnostics can be performed remotely before those technicians even arrive at the equipment. Following on to analysis, where we can actually provide the tools to analyze the data in detail and really understand where we have opportunities to improve and maximize the impact. And then following on from there, putting the actions in place to close the overall feedback loop and improve the system. So really, ultimately, we're driving the operational efficiency of the equipment and how we can really better monitor how the equipment is being operated and maximize the productivity, and at the same time ensuring that the equipment is able to deliver the capacity that it was designed for. To give a little bit of an overview on where modular operates and some of the history of the maintenance systems product line. So we've been a world leader in asset health monitoring since our first release of the MineCare system back in 2012. Since then, we've expanded to well over 5,000 units across the globe monitored collectively by modular mining systems through our MineCare system, and almost 80 sites across the globe. We have 10 sites globally to provide 24/7 support to our products. And really in line with this, we've been able to deliver improvements over time with now more than 175 different equipment models monitored. We've been able to deliver MineCare as both an integrated solution as well as a standalone solution, so it can operate without other modular products on the equipment. And then more recently, today, where we have our MineCare cloud computing solution, which really leverages off some of the latest technology that I'm going to talk about today to really help you drive some of the key improvements in the maintenance operation. So some of the key challenges that we're really trying to address in the mining industry in maintenance. A common problem for organizations is a low mean time between failure, and we see this as a result of defects that have not been addressed, or we may not have been able to identify the root cause of these defects. So we're seeing repeat occurrences of failures on the equipment. Also very regular failures and instances where we're addressing faults or problems on the equipment where it may not be necessary to address those immediately in a more of a breakdown manner. Continue to see high amounts of unplanned maintenance in the mining industry, and often still organizations are operating in excess of 60% of their maintenance activities in an unplanned and unscheduled manner. Low labour utilization is also a common challenge where maintenance personnel are spending a great deal of their time trying to locate equipment, moving between locations, manually completing work management activities, and really not able to maximize their time on the tools, and this is another area we aim to address. And then finally, also around improper equipment operation, where equipment is being operated in a way that is outside of the intended design limits of the equipment, which can lead to reliability issues of the equipment and also problems around the availability. One case study example that we have around driving an improvement in mean time between failure comes from a coal mine where this mine, upon deployment of the MineCare system, was actually able to drive a very significant improvement in their mean time between failure across the entire truck fleet. So over time, they were actually able to see a 150% improvement. And this was really as a result of focusing on the key defects and the high impact areas where they were seeing repeat occurrences of failures, and actually doing the Pareto analysis with the data and using the MineCare system to help ensure that equipment was not going down for the same problems more frequently. Now, one key benefit we see from an improvement in mean time between failure is that there's direct linkages to the utilization of the equipment, and often almost more so than an improvement in availability. And this really comes as a result of repeat stoppages of the equipment having a significant increase or impact in the ability of the operations team to be able to manage those frequent stoppages. When we talk about high amounts of unplanned maintenance and our scheduled loss ratio, where we're seeing a large percentage of unplanned versus the planned maintenance activities, this is a real problem, and often what we see is that the cost of unplanned maintenance can be between 3 and 10 times more costly than maintenance that's performed in a planned and scheduled manner. Another case study that we have, which is based on improving this scheduled loss ratio, was a customer that after bringing the system online was actually able to trigger a very significant improvement in their scheduled loss or unscheduled loss of the equipment. So around a 25% reduction in unplanned events, and this was really as a result of understanding where these unplanned issues were occurring and really targeting those areas. Another example we have around focusing on labour utilisation is from a case study in Chile, and this was really analysing instances where equipment was being stopped unnecessarily, also around targeting improving the amount of time that equipment needed to be down for a problem to be resolved. So targeting an increased understanding of whether or not maintenance stoppages were necessary, and this comes from having the data at your fingertips to be able to effectively make those decisions. And as a result, over time, this organisation was able to significantly reduce the amount of average downtime hours per equipment per month, and significant labour savings as a result. Finally, a case study on Operate for Reliability initiative, where we're able to target operational events of the equipment, ultimately driving that improvement in equipment availability. So a particular organisation was able to achieve a very significant reduction in service break applications on the equipment over time. In a very short time frame, around a 75% reduction in these operator-related events was identified, and then following on to a reduction around 98% of these event types over a longer time frame. Now, what we found is that this actually translated directly into a maintenance cost saving in component costs over time, which translated into the order of over $1 million in the space of a year. So very significant results for focusing on one specific operational related event. So as we move forward with the MineCare system and moving into the domain of Internet of Things and cloud computing and analytics, this is where we get into the ability to really start to intelligently gather data from any equipment type across the mine site, and also integrating different data sources and integrating the data across potentially multiple operations at an enterprise level. So this different data can all be integrated together and then used to drive the actions back at the site level to the people that need that data to make the right decisions and take action. So when we really look at the overall Internet of Things and the different data that we're able to bring together in the system, we start to be able to integrate these different data sources into our advanced cloud data center, and this can include things like the fleet management operational data can be integrated with the machine health data to add that operational context on how the equipment is being operated around the time that we're seeing potential health problems on the equipment. We can also bring in condition monitoring data sources such as oil analysis, which provides more context alongside the machine data from the equipment to actually understand the health of the components and also the oil analysis results that could provide that more detailed information. We can integrate environmental data such as weather data into the system, which can provide that important context around are there weather conditions that are contributing to particular events that are occurring. And then finally also the important link between the ERP system and the MineCare system, where we're able to start to automate the workflow trigger within the system and also generate a feedback loop so that we're actually able to capture activities that are occurring and drive a continuous improvement approach to our maintenance workflow. The MineCare system has the capability in the central level to really start to develop those the analytics capability and develop algorithms. And what we can do with the MineCare version 3 is actually push those algorithms back out to the machine level, at edge computing level, where we're able to more effectively make real-time decisions at the equipment level. So we're actually able to push detailed information back out to the operator on how they're performing in terms of operation of the equipment and how that could contribute to the health of the equipment. We're also able to use that information to provide feedback to technicians as well in terms of the task management on the site. The analytics component is really driven from the central level of computing, and then down from there we're actually able to drive a failure prevention approach and push the data down to people working on the site through mobile device notifications. An important component is our ability to provide feedback directly to the operators, technicians, and maintenance planners. So this could be in the form of alerts to the operators and giving them the capability to have insights from the field into the equipment health, and also providing direct feedback through the operator screen, where we can provide them fast feedback on where they're operating the equipment outside of its design limits, and also where there's a potential major problem on the equipment that could require immediate intervention. So providing a mechanism for storage of big data securely on the cloud is a big area that we're focusing on, and also being able to retrieve this data at any time for more advanced analytics capabilities. So really around separate data stream mechanisms is around how we can manage big data being sent over to the cloud in an efficient means, and also not losing that real-time capability where we're able to provide real-time visualization for key information to the right people at the right time. Another feature that we're able to provide is a Sandbox environment within the cloud, which is designed to give the customer the capability to start to perform data exploration. And this is really around understanding the relationships in the data and being able to start to explore and add the value-adding algorithms. So MineCare has the capability to create user-defined dashboards where we can start to create a visual overview of all of the different components in the system, and then filter down from here from the high-level overview of information into the detailed components of the system. We're actually able to leverage reporting tools for more advanced reporting dashboards, and this is something that is available out of the box, but can also be customized per user for specific views into the data. So we can start to perform very important views around heat mapping of the information on the equipment, around location. It could also be for Pareto analysis purposes, where we're looking at high impact areas of downtime on the equipment or fault analysis. Our equipment health tracking application is a new application in MineCare version 3, and this is really designed to provide a high-level overview of the health of the equipment, where the equipment health will change state over time according to different problems or issues that have been detected on the equipment. We can drill down from here into much more detailed context and correlate the location of the equipment and where it has been operating with the operational context of the equipment, and also the recent maintenance events that have taken place and how they relate to recent faults that have been triggered on the equipment. We can also visualize this at component level, so it's designed to give us that full integrated overview of the important information for that particular unit. data monitoring application gives us the real-time view into the data, where we're actually able to monitor the equipment on the mine site and also correlate that to the geospatial context. This is really designed to be able to leverage that data in real time for diagnosis of a problem that may be being investigated, also for repair verification. And we can also use this data for exploratory purposes, where we're able to define conditions under which we're collecting the data, and also define threshold conditions where it will flag in the system that a parameter is behaving outside of its expected behavior. Our event handling application is really our overview of incoming faults from the equipment, and this gives us the ability to drill down into much more detailed view for each of these faults, where we can provide advanced diagnostic details and help around the equipment faults, and also that operational and visual context on where the equipment was operating and is the problem getting worse over time. This also allows us to provide visual mapping and heat mapping of the alarms. Are we seeing clusters of particular alarms occurring at a particular area of the pit? For example, we could have road condition areas in a particular area of the pit that can be easily flagged, or we could have increased tire temperatures occurring on a particular ramp. This part of the application also allows us to push user-defined events out to the edge computing, where we can define our own alarms based on logic to trigger those alarms on the machine in a real-time context, and also provide that feedback back to the operator if necessary. One area of the MineCare system that we're really able to help with is around our assisted operation that we call our remote care service. And this is really targeting at helping MineCare users get more benefit out of the system. We're able to provide support and monitoring of the system in a 24-hour basis, where we can provide real-time feedback to the customer, as well as ongoing reporting on different items that are being tracked. And an area that we really see this help is that there's various studies that have shown that 80% of failures are random in nature and have a random PF curve interval. And it can be very difficult to maintain a time-based maintenance approach to maintaining some of these components. So we're really able to help to understand the different insights to drive that condition-based maintenance approach. We've also developed what we call our product maturity model for the MineCare system, and this is really aimed at targeting where providing a tool for the customer to really understand their current state in terms of their use and maturity and capability of the MineCare system. So we really take a tiered approach in terms of providing at a high level what are the different categories that we need to address when we're looking at the maturity of the system. And then the idea is that each category to the right can only be as good as its previous category to the left, where we're making sure that we've got the fundamental pillars right before we start to really focus on the change management and how we're integrating the system into the business processes. So this tool is really used, one, for the current state assessment of the customer, and also for gap analysis in terms of how do we match up with best practice of the system, and what does the journey look like that we need to roadmap in order to get there. And just finally, a little bit of a success story around a deployment of our MineCare 3 product at a mine in Canada. So we've been working closely with this mine to improve their use of the system, and they've already been using the capability of the system to develop their own algorithms based on the failure modes that have been generated through the FMEA process. So each of these failure modes has a specific identified detection point, and we've been assisting with actually creating the customized algorithms to detect these failure modes earlier on the machine. We've also seen a very significant reduction at this site in operational alarms as a result, and some of these have been targeted, and we're seeing very positive feedback from the operation and even the operators as a result. The system availability has been near 100%, where we've really seen no downtime of the central system since deployment, and that's been a very good result as a result of moving to cloud computing. And also around engine catastrophic failure, there's been a few occurrences where we've avoided catastrophic failures of engines as a result of early detection of the onset of problems. Road condition monitoring initiative has been another one with particular challenges at this mine site around conditions on the road, and they've really been able to help drive an improvement approach to monitoring those road conditions and providing the information to the necessary service people to act on those conditions and repair the roads in the right areas that need that work. So this concludes our webinar for MineCare Cloud. Thank you very much for your time today. If you have any questions, please make sure you put those in the space provided. And really, to sum up, this presentation is designed to give you an overview of where modular is headed in the area of innovation in Internet of Things, cloud computing, and analytics, to really create a digitized mining approach where we're able to give the right data to the right people to make a more effective maintenance decisions. Thank you very much.
Thank you very much, Simon. Several questions have come in, and we do have just a couple of minutes to address a few of them. If we do not get to your question, we will follow up with you via email within the next 48 hours. So the first question that came through is, what happens if the site loses its internet connection?
That's a very good question. How we manage the occurrence of loss of internet connection from the site to the MineCare Cloud, we have onboard store and forward capability on the individual devices operating on their mining equipment. So this store and forward capability will maintain hours of data storage while we're losing the internet connection, and we still have the edge computing capability on board the equipment to deliver key information in real time to the right people. As soon as that internet connection is re-established, all of the data that's stored on board will be forwarded back to the cloud for centralized computing and storage.
Fantastic, thank you. And how is the health level of an equipment unit determined?
So where we're looking at our equipment health tracking application, this is actually able to provide that overall context of the equipment health. Now this is determined through a number of different things. One of those is the active faults that are occurring on the equipment, and also around the different parameter behaviors on the equipment, and are those parameters falling outside of different threshold limits that have been set on those parameters. So it takes into account a couple of things, as well as things like communication and interface loss in building a picture of the overall health of the equipment.
Okay. Does the dashboard display over multiple screens?
Yes, the dashboard can be extended across multiple screens, so we can actually create duplicate instances of the dashboard screen. So if we want to have separate tiles across multiple screens, it's very easy to replicate the dashboard across the multiple screens and actually have this managed across those different screens in terms of the important summarized information that needs to be displayed.
Okay, great. And it looks like we have time for one final question. It says, with more sites coming on board, do you have contingencies to larger servers, etc., to cope with system availability?
So I guess one real advantage that we're taking advantage of in moving to cloud-based computing is around the scalability and redundancy capability in cloud computing. So if there's a requirement to really scale up to a very large scale data storage, we can very easily achieve this with our data lake storage environment. We can also create duplicate occurrences of data sources so that data can still be accessible in the case that there's any issue at a particular data warehouse, for example.
Wonderful. This wraps up our questions for today. We hope this presentation was informative. I apologize, we did go a little bit long. If you have any follow-up questions or comments, you can contact us at products@mmsi.com. That's products@mmsi.com. Thank you again for your time, and we hope to see you in one of our future webinars.
Thank you.
Okay.
Was